Hello, Microsoft Power BI fans. This is Scott at Tiny Lizard. Uh, and this is your second installment of the Real Experience. Um, this is episode 1, part 2. At the end of part 1, we had kind of finished doing some Power Query work, and we were trying to pull that into Power Pivot, and it wasn't working really good. We expected about 7 columns, and instead we got 1. So that made us sad, and so we're going to have to try and work around this. I honestly don't know a great fix for this until I can reach out to Chris Webb, and hopefully he can help me get a good answer. We're gonna do a mediocre answer. So let's get started here. What we're gonna do is oh, that's fancy. Well, let's try some easy steps first. We can come in here, go to design. Let's just delete this table. It's not working anyway. Delete this table. And, we can just kind of try again, right? And the way we know that this works is we don't see this. If you see this, select asterisk from, you're kind of in a bad state because you really want to see a better UI where you can select columns and stuff. So that didn't work. The way I fix this, and I should use little, air quotes around fix, is to load this to a worksheet. And if you do this, it seems to fix the issue. Let me show you that now. Go in here, design, existing connections, double click, click next, and what we're going to see is like this better experience here, right? Where you can select from a list of tables, you can preview and filter. Here's all of our columns. So this is really what we were hoping for, right? And then once you're done, you can come back here and you can actually turn this off. Just sort of save some workbook space. And this should, actually continue to work. I can go and refresh all, and it's fine. While I'm here, let me show you one more thing. So let me go back, load the worksheet. It doesn't matter what sheet I'm on here. It shows this query here, right? So what I'm thinking is it should be safe to sort of, delete this without impacting Power Query. But now I have no queries. I did not expect that the first time it happened, and I'm not really sure why that happens, but it's not a great thing to happen, especially when you can't remember what you called your file. There we go. We're going to reopen this thing. Power Query. All right, so we're back to having this guy. We're going to load to the workbook. We are going to go into Power Pivot. If I refresh, does anything good happen? No, that didn't help me. So we need to delete this table. And then we need to delete that data source, make a new one. And okay, we're in Happy Land. Okay. So now that we're happy, ish, what's wrong with this workaround is that if you had a lot of rows, you couldn't load it to a worksheet, right? I mean, maybe if you're more than 1 million, Excel just wouldn't even let you do that. And that's kind of one of the great things about Power Pivot is you can have 50 million rows if you want. Obviously, if you have to work around bugs this way, that's not going to work out. So we'll want to find a better fix than this. But in our case, we don't have that many rows, so we're just going to steamroll past that to get along to some other work here. Okay. I'm not going to do anything fancy here. I'm not going to make like some new tables, calculate columns, import a calendar table and link that up or whatever. We're just going to work with this one table. And what we see is, we have 2 types of data. We have the dropouts and we have the students. And so we're just going to write some base measures here, like, hey, how many dropouts are there? How many students are there, right? And I can do that back in the Excel window, or I can do it here. I'm going to do it here because, well, I'm here. Total students is equal to calculate the sum. Uh-oh. Okay, I broke one of my own rules here. I'm going to hit escape and just lose this fine typing. This is education query, which I don't really like, right? I want this just to be education or something. I don't like spaces, and the word query isn't terribly useful. State name, I don't know, I'd prefer they call that a state. If you don't make these types of changes first, you're probably never going to make them, because once you've written measures against them, you can't rename them and expect those renames to propagate. It's not smart like that. So you could rename a table and you just broke a bunch of measures, and then you're back in Sadsville. So it's really best as soon as you bring in a table to do some work. Do I want all these columns? Are they named correctly? Do they have the types that I like? Text, whole number. So I'm happy with that. And now I like these names. So now I can move along. Okay, so total students, equals, calculate the sum, table name, I keep doing that, table name dot column name. I said dot when I meant bracket. And the reason we have to calculate here is because we need to filter, right? We have two types. We have dropouts and the student enrollment. And so to filter this down to just students, we're going to put education type is equal to students. And what we expect to see here is, some number of students. What we do see is blank, and this will perplex us, right? If I put total equals the sum of education bracket value, we get a number there. Format it, 7 million total, but that's not useful because it has both dropouts and students in one. So we double check our spelling here. Students, plural. Students, plural. So it's not that. And I've written a few calculates in my day, and I'm pretty confident that's correct. So what is going on? Let's select one of these guys. There's no weird, well, maybe there's a space at the end. Yeah? Maybe there's a space at the beginning. I'm not really sure what's going on in Spaceville, but it feels like there is one, right? So if contains, that's not what I meant. Well, how about this? I don't know how to say, is it find? Must be find. Starting position of, yeah, there you go. I want to find a space within this column. And I did this totally weird with an if. And there's a space at column 1. So there may be one at the end as well, but there's certainly one at the beginning. So we just have bad data here, and so that's why we were reading back a blank, because nothing was equal to student. There was only space student or space dropouts. We could try and fix this here by replacing that space here in a calculated column, but now I have this duplicate column, and I'm just taking up more data space than I need, and that's wasteful. So let's not do that. Instead, we're going to go back to Power Query and fix this, okay? So, we'll come here, edit. Now, we can try and figure out, like, hey, where'd this guy come from? Somewhere in this stack, but honestly, I just don't care enough to do that. It's just so much easier for me to just come here and say transform, replace values, replace space with nothing. And say OK. If we watch this carefully, we'll probably see it shift over there. Did you see that? And so now we're happy, I think. I'm not really confident where to load this guy, but I think let's stick with loading it to the worksheet here. Okay, so, that looks good. Come back to Power Query. Power Pivot. Bring up our window and drop a refresh. And in all its glory, we see an error. Something about an OLEDB provider, input modified, Power Query, blah, disable, re-enable, blah, blah, blah. So, I think what's happening here is All this encoding stuff here is like our logic for our power, some encoded version of our Power Query, and we changed that. It's now like doesn't match anymore. Theoretically, we can kind of probably go back into Power Query, find out what it's using, and then edit this guy to update it so it matches, so we don't lose our work here. I've seen some blogs on that. Google around, Bing around, and you'll find that. I haven't done enough work here to justify that, so I'm just going to delete this guy. And delete this guy. And then just come do this again. Okay, we're going to bring this back in, and we're still in Happy Land here. Finish that up, and then again we're going to remember to rename education and state. And now we're going to go rewrite, calculate the sum of education value, filtering on where the education type there we go, is equal to, what is this? Total students. Where it equals students plural. Close off our parenthesis, and bam, we actually have a value this time. So that was annoying, but we kind of noticed it early, and we're able to get around it. I'm gonna copy paste this guy and say total dropouts. Change this to dropouts. And then go ahead and format this guy with a comma because we love that action. And so there we go. We got the total number of dropouts and the total number of students. We're not really interested in absolute values because, obviously California has a lot more people than Alaska. And so the number of dropouts between those is it's not terribly interesting. But like the percentage of students who drop out, that probably is more interesting. So let's go ahead and divide those two and say the dropout percent is equal to the total dropouts divided by the total students. And we get a percentage here that looks like 12.5%. Now, right off the bat, I'm thinking, wow, that's a big number. Either America is in much worse shape than even I, the eternal pessimist, thought, or our data sucks. Probably the latter. So we're going to find why our data is no good. And so let's just dig in and do that. Let's go make a pivot table on a new sheet here. Total dropouts, total students, the percentage. And if we put like sex, it didn't look very nice. Okay, so those both look reasonable-ish, and in fact we already see a couple interesting things here. Males drop out more than females in our bad data, and then we have some divide by zero problems. Let's deal with the divide by zero first. So I'm in Excel 2010, and it lets me just edit the measure right here. If I was in 2013, I would be off into some other dialog, and that's annoying. So I'm using 2010 because I enjoy just being able to say edit measure. And then I will divide through this function instead of through the just using the operator. Check my formula, hit OK, and then now instead of giving an error, it just gives me a blank, which is nice. So use the divide function as opposed to doing an actual operator divide if you think you might be dividing by a zero or a blank. Okay, so we're still not sure why we're sad though. Let's get rid of our workbook queries. Let's put the year range here, and that makes things pretty clear. Apparently we have no 2008, but all of our dropouts are from 2004 through 2009, and then all of our total students are from 2010 and 2011. So total mismatch in the data. So what do we do at this point? Do we just say that this data stinks and go about our happy lives? I don't think so. So, I mean, these values are all pretty, whatever. They're moving around between 145, 155, and 199. These ones are actually pretty consistent. You know, if we kind of took the average of these numbers, divided by the average of these numbers, you know, we'd have something pretty valid. You know, this is a terribly high number just because we have more rows of dropouts than we do rows of total students. So let's figure out what the average dropouts are per year. Okay, not just the average dropouts. In fact, let's do that really quick. Average dropouts is equal to the average. Well, we're still going to have to calculate here, aren't we? Calculate the average of education value filtered by education type. I really wish completion worked less sucky. Oh well, we'll give up on that. Education type is equal to dropouts. Check it. Oh, well, that's why. Calculate. That's probably why completion wasn't working. All right, so 310. I mean, what is that? So that's actually like the, you know, the row average, which is like the you know, for 2004, there was an average of 310 dropouts per sex, per race, per state, right? So that doesn't really help us. We kind of want the yearly average. So how are we going to do that? Let's write a new measure here and call it yearly average dropouts. And there's probably going to be a call to average X here, right? I want to take the average of something rather. But that something's not a straight table column. It's something else. In this case, it's going to be whatever is in this cell. So the values of education year range, right? So that's going to return us a table of you know, when we're in this row, it's only going to return 2004. When we're in this row, it's only going to return 2005. When we're in this row, it's going to return us, you know, all 7 of those years, and then we'll average them together, right? What is the value that we want to average together per year? Well, it is actually we already have it. It's the total dropouts. So we're saying, you know, at a year level, what is the total dropouts? All right. There's no errors. We hit OK. Okay, and of course, I didn't format that, which makes me a sad panda. Of course, you know, here this matches, right? I mean, 145, 145, 173, 173. But here, instead of just being the all-up sum, it's now the average of the values above it. Okay, so the yearly average dropouts, and then let's do the same type of thing. I'm going to copy and paste this, write a new measure, the total students, yearly average students. Check that. I likes me some commas and no decimals. All right. So on average, there's, you know, 3.4 million students and 173,000 dropouts, and you know that sounds a lot better than 865. Let's just go ahead and modify our dropout percentage. We'll just modify this guy to take it from these yearly averages. Yearly average dropouts divided by yearly average students. Check it. It's happy, and now we're at 5%. So that's great. So let's start seeing if this can help us find any insights here. Let's throw some sex down here, and apparently I can't look at this. I don't know why. I don't know why I can't see this by year. I'm sure if I thought hard enough. Oh, so that division's never really valid, right? On a year by year basis, because we never have both students and dropouts in the same year. So we're not going to look at this on a yearly basis. We're just going to look at this, in aggregate. So here we go. By sex, males drop out, a fair amount more often than women. Um, let's put these guys over. On rows and put, let's say, state. And then let's sort by largest to smallest. Holy smokes, Arizona. What is going on? Let's do some conditional formatting so we can see this a little better. Dropouts are bad, so we'll make that red for high. And then we'll fill this out here. And there you go. The cream of the crop, if you don't want to be dropping out of school, is New Jersey. At just 1.8%. That's seems pretty fantastic compared to 10.5% in Arizona. A really southern state and a really, really northern state. I have no explanation for this, of course. Let's go look for some color discrepancies here. So this looks kind of interesting. Like this is a little more red than most. 5.9% versus 8.2%. So like a really large degree of difference between the males and females in Michigan. That kind of interests me. Let me, if I divide those two numbers, I can kind of get the ratio of male to female dropouts, and then we can sort by that and see if we can get some insights there, okay? How we do that? Well, I'm going to divide, so let's use the divide function. We're going to calculate the dropout percentage, and I believe completion messed with me there. And we want to filter this on education sex is equal to male. And then I probably need to close off my calculate. Seems like a good plan. And female, we don't need that. Close that off. Check it. That's valid. Let's call this the male to female ratio of dropouts. Check it. Let's make this a percentage, 1 decimal. Hit OK. It's kind of a mess. Let's get rid of that. Male to female dropout ratios, and let's actually having sex on there is not terribly useful, is it? And let's go ahead and color code this. Actually, first let's just sort this guy largest to smallest. Rhode Island has the biggest discrepancy apparently. And actually, now that we took sex off there, yeah, so the male to female ratio does not change just because you're looking at a male or female cell, but we can add back in the dropout percentage here. All right, so then we can actually see what the actual numbers are. And now let's color this guy. Conditional formatting. Red is bad. Fill this into that. That looks good. And of course, we had sorted that, so the very worst, I guess, if you can call it. Yeah, I'm going to say that. Let's go ahead and make a bold statement that this is not a good thing. males in Rhode Island drop out 50% more often. Is that what that is? Than females. And of course, I have no idea why, but like, there's not like a huge drop off between these guys. It's kind of a mellow change here. We're scrolling down to see. Okay, that's right. Okay, so two things to notice here. One is that 51. No. How many states do we have? There's 50 states plus I think DC is in here. District of Columbia. 50 of 51 places have males dropping out more often than females. Okay, the number's above 100%. There's one place where the reverse is true, and that's Texas, where females drop out more often, and like not even like the drop off here is extreme, right? Like everyone else is like, okay, 109, 113. It's just kind of like this smooth gradient of color change, right? And then all of a sudden you get to Texas, and it's like, bam! I have no idea why, and I'm actually a little bit interested. If somebody knows, tell me. But overall, their percentage rate isn't too bad at 5.5%. That's not terrible compared to some. If I sort this, 10%, 9.4, 8.7. So they're kind of, I guess, middle of the pack there. But the large discrepancy between male and female, I thought was pretty interesting. Okay, so what else? I guess instead of by sex, look at this by race would probably be interesting. Our color coding still works here. We're currently sorted by the dropout percentage still. Aren't we? Sort largest to smallest. Yeah. So remember, Arizona was the worst, and it's not like there's a huge discrepancy. I don't really care about male to female anymore. Let's color this. Conditional red, and let's fill this down. Okay, so Arizona's the worst, but if you're, Asian, not that bad. However, if you are an American Indian in Arizona, you're not rocking. Though if you're an American Indian in Colorado, you're super not. Actually, American Indians in general seem like they're not rocking. We didn't really look at that. Let's add a separate table here. Again, we're in 2010, so I could just go add a new pivot table right here. Can't do that in 2013 because Microsoft hates me. Let's put this here, and let's do by race dropout percentage, and I'm apparently addicted to formatting things in pretty colors. Hawaiians are awesome. White not far behind them. But you're talking 3 times the number of American Indians drop out compared to Hawaiian, Asian, and white. Maybe 2.5 times, but and then Hispanic and black not great as well. So American Indian seems to be kind of the worst in this data set, assuming that the data collection is valid. Like I don't really know how the data collection worked. On the reservation is a little different or whatever, but certainly it looks really bad here. And there's no reason to believe that Hispanic or black are any different than, white, Asian, Hawaii. There's no reservation, issue there. And yet, obviously, 7.3 is terrible compared to 3.0. Okay, so by state, let me get rid of this guy. We saw that. We got our insights. We don't care. I'm going to put race on columns instead. Apparently, if you are Hawaiian, you do not live in Colorado or Maine. You live in Alaska, California, though not Wyoming or Hawaiian. Not terribly surprising, I guess. So here we can look for outliers like in DC, if you're Asian, you're doing terrible. Even though in general, the Asians look really good. Not great in Utah, terrible in DC. I see a lot of redness here in the American Indians, of course, which doesn't really surprise us, though. If you live in Maryland, South Carolina, you're not doing too bad there. In DC, assuming that's valid, 0. The worst place to be as a black person is Wyoming, Colorado, California. Man, not impressed with you, California. What do we say about the Hispanics here? Again, Utah and Colorado, not great. In Alabama, you're Hispanic. And in Vermont, I don't know. So anyway, kind of interesting. I don't know if we looked at this on a... Did we already look at this on a per state? Yeah, we were to the Arizona sucks. And I'm very disappointed in you, Arizona. But there you go. We're a little bit past a half hour in here. We saw some insights based on, per state, race, sex. Really in the all up here, we're looking at, just over an hour of recording time. And we went from grabbing data off some website to, getting upset with Arizona. That's actually pretty amazing if you think about it. I'm a huge fan of Power Pivot and its power and its, I love its formula language, and that's something I've really embraced. Power Query is a little new to me. We saw some quirks, but even there, like knowing very little, I was able to massage this data into a format, which got us to this point. And I think if I didn't have it, what am I doing at that point? I'm trying to get my data into SQL to unpivot it in SQL or something, or I'm writing custom PowerShell, or the traditional ETL would be SSIS, but like the barrier to entry there is, I think it's quite a bit higher than Power Query. So I'm this project here definitely kind of, I turned the corner on Power Query to thinking, wow, like this thing is real. And I haven't even dug into learning, the formula language M. I think once I do that, I'll probably be, that much more impressed. So there you go. I hope you guys, found that useful. I had a good time. Hope you guys did too. And, we'll try and do another one of these, and we'll find some new data sets, find some new insights, and you guys can again watch me, struggle end to end. But once we get there, we can look back and say, that wasn't that bad, and this is pretty cool. See you guys next time.